Welcome to From Carpool to College, a show for parents who are trying to get ahead or just keep their sanity while navigating the college planning landscape. Welcome to From Carpool to College. Thanks for joining us today. I'm Tracy Amadeo.
And Tara Horitz.
And Professor Tom.
Professor Tom is in the house with us for another episode, and we're going to talk about engineering. This is very specific. This is from Carpool to College. So we're talking about college, but we're also talking about careers. And I get a lot of this when I'm in social circles or even professional circles, and people find out I'm a career counselor and a college counselor. But I hear a lot of this comment like, oh, well, my kid loves Legos, so I think she's going to be or he's going to be an engineer. And I think about how Legos covered the floor of my home from when my kids were maybe out of the oral stage up until about 7th grade. And neither of them are inclined to be engineers. So, Tom, could you address my Lego comment, please?
Yeah, absolutely. I love it. And we hear that a lot. I have a lot of students that will say, oh, I really love robots, or I really love Legos, or, I've even had some that would, I don't know if I'm dating myself, that would say, oh, my erector sets and stuff like that, or Connects. And, these are all kind of games and stuff that are available for children. And, being good at Legos shows creativity, shows spatial thinking, which can be helpful in engineering. There's nothing wrong about that at all. But engineering really is problem solving. It's math. It's persistence. Legos are a great starting point. They are not a guarantee. And I think one of the things that we tend to do is we say, oh, Legos, they're they built this awesome thing, or they were able to do that. And sure, if you've got that creativity to solve a problem that doesn't exist and just make something, we all wish we lived in that kind of world, right? But, engineering is really, really about sticking through hard challenges and problem solving and being able to be persistent. That's the big thing in engineering. So I usually like to tell folks that make that comment of that's a great starting point and a great compliment, but let's not pigeonhole ourselves into a career too early.
Right. Because
we don't know anything about it. Legos are not engineers.
So, because Tara and I work with so many clients in college counseling, and the undecided student is a thing. And we have ways to help students weed out. Sometimes it's easier to say, well, this is what we don't want to do, right? We don't want to do X, Y, or Z, which is great. We're seeing a lot of students interested in engineering. And we're going to take this episode because we have an engineering professor in the house today.
How lucky are we?
We are so lucky because on many reasons we're fortunate and blessed to have Professor Tom with us. But we want to take this opportunity, and many of our listeners right now will just turn off and say this episode is not for me, and that's fine.
And that's fine. Yeah.
But there are a lot of parents who are going to wonder, what does an engineering career look like? What are the different types of engineers? And what is the prototype of that student? Because I got to be honest, when I first started working with Professor Tom 10 years ago, maybe?
Yeah, about 10 years ago.
Something like that. We partnered in a program where we put high school students in college early for mechanical engineering. Right. And frankly, I didn't know much about it. I didn't even realize that my dad was a self-taught mechanical engineer. I just thought he was kind of a very mechanically inclined, and he worked in production, and I wasn't sure. He was a factory worker. And then when Professor Tom was explaining about mech tech, as they call it, it's very sexy when you call it mech tech.
I know, right? Yeah, it's got a good...
I'm mech tech. Wow. But I realized, wow, that's engineering. So if we can today, I did use a little ChatGPT, I will say. I asked ChatGPT. This was my prompt, Professor Tom. Here we go. List the different types of engineers and what kind of academic student finds success in each.
That is a great Great question. So for those that are interested in engineering, before we talk about all the different disciplines, I'm going to tell you how they're connected.
I love it. See,
Right.
this is what
So-
an engineer. He's engineering an answer right now.
I'm engineering an answer right now, and I want to kind of connect it a little bit to what we were talking about with that Lego comment,
Yeah.
right? So, we said being good at Legos means that you're creative and you're curious and you may have some good thinking, but engineering isn't about building things. It's about solving hard problems when the instructions disappear.
Oh. So it's like when I clean the floor with
Yeah.
all of the Legos,
Right.
put them in a shoebox.
Exactly.
And then said,
make this.
make a
There's no
shoe holder
instructions
for Mom.
The instructions, whatever you made was already disassembled and in pieces, and you don't know where all the pieces are. They all look the same. They all look different. And so engineering at its core is problem solving. It's rationalized thinking. And I had used that word, and I'll bring it up again, persistence, right? So engineers are almost obsessed with the problem, but not in the problem itself, but in ways to solve the problem. When I was a young engineer myself and working in industry, I was always committed to solving the problem. And when I would make a mistake, I would be, of course, embarrassed, and I talked to my manager or what have you. But, as you're getting scolded, I'm like, can we just get past that? I think I found I think I found the solution already.
As you were getting scolded.
Right? Like, I think I figured out a way to kind of correct this, right? So engineering as a career and a focus is all about being able to solve complex problems. The disciplines really have to do with you as an individual. What are the types of problems you want to solve, right? It's not the career I want to go into. Every engineer, every discipline is going to be a problem solver. And that's what you're trained. Engineering in higher education, I had an advisor, a mentor, a wonderful professor. His name was Dr. Mahalia Prasad. He taught over at Stevens. And he was into acoustics, and he was a mechanical engineer. And a very insightful man. And he had said that with engineering, we're here to solve problems with the tools of science and math, right? So we use those tools
of science and math. We're going to get back to that.
Absolutely.
Yes.
And so as you took our classes, they were giving you tools to put in the toolbox. So that way, when you were out in the field, you could leverage these tools to solve complex problems. But really, you're a problem solver. And you go to school not to learn necessarily the individual discipline topics, but you learned how to think. That's what engineering in college does, is to teach you how to think through the problem, how to be persistent, and how to utilize those tools. Mm-hmm. So knowing that that's all engineers, now let's break it up into what different types of tools would you like to play with, right? If you're a mechanical, so mechanical is the original engineering discipline. When
the OG,
yeah, the OG, start, and then we have our professional society, the American Society of Mechanical Engineers, actually started in this area over 100 years ago, believe it or not, and they are headquartered in Montclair, New Jersey. So
Jersey,
rep in Jersey here, but the ASME was started as a professional society because a mechanical engineer in the age of the Industrial Revolution was the engineer. You worked on equipment, you worked on machines, and you made things work. That's the whole idea. And in the age of discovery and invention, there was a lot to do, but of course technology changes. And with that, the other disciplines start to come into play. So we've got electrical engineering, we've got chemical engineering, and we've got civil engineering. Those are the core four, if you will. They are the mother disciplines of all. All right,
so let's go back to that because my auditory recall is low. So the four in your assessment, the four core engineering realms, if you will, teams is mechanical,
electrical, chemical, and civil.
Okay.
And civil.
All right.
So from there, all the other branches kind of are offshoots or they're interdisciplinary mixes of the two.
Okay.
So if you are an engineer who's focusing on automation and robotics and industrial applications, that's some mechanical and some electrical. Let's say you are an engineer that's working in construction and in the structural realm. Well, there's plumbing, there's HVAC, there's still electrical, there's the structure itself. So you've got some mechanical, you've got some electrical, you've got some civil. It's a crossover.
Right.
If you are an environmental engineer, you are going into the hard sciences with biology, but you're also touching into the civil area with wastewater management and other types of areas as well, right? So there is a crossover. In chemical, if you're in pharmaceuticals, if you're in biomed, chemical is engineering is, a lot about processes and how we can get these things made and to reach certain levels of efficiencies and purities and things like that. You'll find a variation of each of these out in the world. And in a world that is increasingly global and interdisciplinary and trying to stay ahead of technical trends, you're going to see a lot of hybridization amongst all of these. And that's your biomedical and all these other types. So even though we're in the core four, a lot of students, especially as undergraduates, they want to get into, I want to be an aeronautical engineer, or I want to be a biomedical engineer. And it's like, okay, well, great. Your first 2-3 years are going to be out of the core discipline anyway.
Right. It's almost like when the kids go to med school, it's like you're going to start here and then you will specialize.
Exactly.
Right.
And so
Okay.
engineering follows very much a similar model. And so you have to have a strong foundation. And that's the only danger with some of these programs is you get a student who is, focused in one career cluster. They're focused in one industry that they really want to get into. And they say, oh, well, this major matches the name of that industry. But that industry employs all different types of engineers, right? So
we talked about this week with my client.
Right. So they pigeonhole themselves. And then, the only difference between them is maybe 2-3 classes, right? And so you really got to think about, and this is the whole thing about engineering, I think, as just choosing it as a major. And this is crucial. Just like being a doctor. How are you going to learn the foundations well enough so that you can build everything else off of it? If you have a shaky foundation in engineering, you're going to have a shaky career no matter what fancy kind of discipline you want to go into. So if it's mechanical, if it's a small school, if it's a project-based school, if it's applied engineering versus engineering science, what teaches you and how do you learn engineering the best? We have a lot of folks that are really great visual learners, tactile learners. They learn by doing, but they feel like the only way they can be an engineer is to do high-level theory and be in a textbook the whole time. So I have to question, will you really understand? Will you take that back and use it to solve problems? Are you going to have that ability? So you really, I kind of tell folks it's like being a DO or an MD.
Oh,
right?
That's a good
So
comparison.
if you go to the emergency room, you're not checking with your doctor to see if they have an MD or a DO. You just see them as a doctor. That's the same thing as an engineer. Whether you're a technology or applied engineering or whether you're the engineering science, they both make engineers. But what pathway teaches you to be the engineer?
But how do you, as a professor, how could a kid how could a kid understand and a parent understand, my kid should go the applied track? And what does that look like?
Yeah. So for engineering specifically, that a lot of has to do, I distill it down to 2 questions. Are you a why engineer or are you a how engineer? So I'm a Star Trek fan and I love Scotty from Star Trek. I know, right? Who would have thought? And surprisingly, though, a lot of students nowadays don't know Scotty from Star Trek, or at least James Dugan, I think, was the original Scotty from Star Trek, the Scottish. I think that was the actor's name.
We're old.
And so, he's like, I'm giving it all I can, Captain, right? That guy, right? the image that we have as the engineer is that I need something to happen. I need a problem solved. That's the person who's going to solve it. So going back to those tools in the toolbox, do you have those tools to solve whatever the problem is, right? So engineer is nowadays used a little bit too ubiquitously. People keep throwing around the word engineer in a lot of positions when you're not really an engineer.
But what really are they?
So, they're usually when they're involved in a technical role. So I think over the past few decades, we've in education, specifically for engineering, we kind of took this view of creating corporate workers with technical skills. Ooh. And so you're going to be a manager, you're going to be a project manager, you're going to be in a cubicle managing technicians or technologists or other types of applied folks. But we're seeing a big shift because nowadays those folks that were trained and that had those careers as technicians and technologists and the applied engineers, they're retiring. And we have a whole generation of folks that went to school to be engineers, but they never left the textbook because their job was...
They can't turn that wrench.
Right, they can't turn that wrench. And so now we're seeing the skills-based and applied gaining value because industry has a deficit there, and they're looking for it. So when I go back to the how versus why engineer, how do you, when you solve that problem, when you're pushing through with that persistence, what satisfies the itch? Once you've solved it on paper, are you satisfied? And then somebody else can figure out how to make it happen? Or are you the one that wants to see it reach that final fruition? You want to see it and make it happen. You're less interested in the, what's the next step? You're the one who's going to bring it to life.
Got it,
right?
like the think tank versus the production line.
Exactly. And so engineering science, which is the traditional route that we have been making engineers for the past few decades, is your calculus and your physics and all of your theory. And that, as a project manager, that gives you understanding, but it may not give you skills to actually do. Right. So whereas the applied, and some folks mistakenly think that you're a mechanic, right? Or you're a technician or something like that. Right. So that really isn't the case. You just kind of know how to make it happen.
So parents need to understand that engineering kind of branches off with the applied versus the engineering science.
Yeah, absolutely. So just like that MD and the DO in the emergency room, less theory, more time in residency, right? Versus more theory, less time in residency.
But we do have to talk about math, Tom.
Yeah, no, and so there is a bare minimum standard, right?
Right. So what is, because as college, Tara and I are both, as you know, we're independent counselors for college planning. Yep. And when we look at transcripts, and Tara knows, we look right away, look at the math strand. Like when a kid says they want to be an engineer, the first thing we do is we look at the math strand. Yeah. And we want to see the termination of the math path. We actually have an episode on this. The math path, I think it's in season 1. We want them terminating in calculus, right, Tom? Like calculus or pre-calc?
I think in an ideal world, calculus, sure. But honestly, the engineering science curriculum starts at calculus. Right. So if you're coming out of high school with pre-calculus, and again, solid foundation, we cannot build strong engineers on shaky foundations, just like you're not going to build a strong doctor.
Right. So metaphorical.
Who doesn't know anatomy and physiology very well.
Or has
right?
never worked on a cadaver in med school.
Exactly. Right. Like there are some things. So I would much rather a student graduating high school with a strong understanding of pre-calculus than a shaky foundation of calculus. Because guess what? We're going to have to teach it over again anyway.
Oh, my gosh. And what happens is the kids get the 4 or a 5 on the AP Calc AB their senior year in high school. But we talked about this in another episode that they've learned it purely for that transactional grade and not for foundational knowledge. They get placed into Calc 2 as
and
freshmen.
Crash and burn.
Could get a D, a W, or a C. And it's like, well, C's get degrees, but they won't get you into the engineering program when you have to apply as a junior.
Right. And you know, and I don't think a lot of folks really realize, because they just see it as a math class. For many programs, Calculus 2 is our barometer. It's the engineering weeder class.
Tara
right?
and I, as humanities people, Tara is like, I got to get Tums for you now.
Yeah, right.
Tara is, she's a writer.
Yeah.
we are arts.
So you gotta like having your 4, 5, 6 semesters of calculus, right? The different because again, math tools, right? That's engineering is very unique because unlike the pure hard sciences, we're applied, and the only way that we can converse across all these different areas and have tools in all these different areas is we have to have a common language, and our common language is calculus. So this is a fluency problem. I'm not going to ask you to be a Spanish major and you can't even ask to go to the bathroom, right? So
right, right.
So for engineering, that's calculus. So, but here's the thing that I think a lot of folks don't realize: calculus is a learned skill. And, I could pontificate about the beauty of calculus. I think calculus
God, says no one ever on this side of the studio.
I think calculus is like poetry.
Oh, my God.
And there is a beauty to it. But it does require understanding, right? So I think when you have students coming out of high school, the other thing I'd also like to mention is a lot of times they think they're taking pre-calculus or calculus, and it is not college level calculus, right?
Oh,
or
right.
it's not calculus pre-calculus at a college level.
It's the Rocky 3 syndrome. It's when Rocky has to fight Clubber Lang and Mick says, "They were all chumps, guy. This guy's going to kill you."
Yeah,
He's
right.
That happens in high school. It's the Rocky 3.
Yeah, we get a lot of students that say, "Well, I took pre-calc in high school. I don't understand why I don't know this." And it's like, well,
because they were chumps.
Yeah, they were chumps. I don't know what to tell you. I feel bad, my dude. But let's see what we can do.
Yeah.
And so there is an expectation that I think let me rush through as much math as possible, and
Yes.
you definitely, if you're going to be an engineer, you definitely want a strong foundation, however way that plays out. So if you're a high school senior graduating with pre-calc or honors pre-calc or something under your belt, and you're solid, and you can do that stuff, and you feel comfortable in understanding, you're fine. You're okay. You're I'd say the standard track. If you want a little bit of a head start and you have that ability, then hop into calculus.
But I would argue, seeing what I'm seeing with my students, getting with the college and keeping in touch with them and my clients, I would say retake Calc 1.
Oh,
in college.
for
In college.
Semester 1.
For sure.
Don't get placed into Calc 2. Yep. Retake Calc 1. Be the queen or king of it.
I
know
would agree
it
with
enough
that
so you can be a TA or a teacher.
Yep.
And that is when you're ready. I think kids think just because they got a 4 or a 5 on the AP test or they had A's in calc or pre-calc that they have a sense of mastery, but that is just achievement. And it is not that intimate knowledge that you're talking about, the poetry, God help you, bless your heart, Tom, the poetry of calculus. Can they recite those
Calc
stanzas?
1 is foundational. Honestly, I would say out of all the calculus that you'll take in engineering, the most important calculus course you will take is Calc 1.
Yeah.
Because it is so foundational to everything else in the conversation that we have. If I go back to the comparison of a language, that's how you're going to learn your grammar, your sentence structure, and the basics of conversation. I don't need the upper level vocabulary. I need to know how to speak the language. And that's Calc 1. And if you can't do that well, everything else is just going to be a toe in the line to get it through.
Yeah. Yeah. And we have so much assistance about, when we're in high school, we have so much support. What comes up with Tara and I talk about this all the time about AI.
Oh, right.
Right?
Yeah.
So we talk about AI, students.
Elephant in the room.
The elephant in the room is AI, and it's about leveraging AI for learning or using it as a cheat.
Yeah. Yeah, exactly.
Yeah, so we could have a whole episode on AI, to be honest with you, and I'd love to share thoughts. And I have colleagues that feel very differently than how I do about AI. As an engineer, we look at these technologies as tools, and so I view AI, of course, as a tool. I do allow it. I actually integrate it into some assignments in my class because I don't want students to just look at it as some clandestine form of, circumventing learning, right? I'm sure there's a lot of folks that would equate it to cheating all the time. But if we had a similar conversation in the, 60s and 70s when calculators entered the classroom, they're no longer going to learn math, right? And, I think that's a little fear-mongering on it, in my personal opinion about AI. But AI is not a calculator. It's a much more powerful tool. And I think if utilized responsibly, it could elevate how a student engages in the material. So, for example, one of the ways that I use AI is I will have a student generate a complex lab report. And we have an open conversation about how do we communicate very technical information easily to folks who are not of that area. And so I'll ask them to utilize AI as a feedback consultant on how they can retool the report with different types of diagrams, with a better, change in the vocabulary to make it a bit more communicative, right? Make sure that somebody understands the goal of what's there. I'm sure an English faculty member might be telling me that I'm taking away their ability to review and critically change. But that's, from an engineering perspective, that's not my particular focus there. It's to try to introduce this as a tool it's not about the output. And I think that's what I want young people to understand, because I see ChatGPT every day. Listen, parents, tell your sons and daughters that we know when they use AI 100% of the time. If I see a report come back with the word superfluities in it, I know Timmy or Susie did not pick up that word on the fly, right? And the structure and just everything about it, I would much rather they use it to converse on the topic, to help develop their own thoughts, use it as a sounding board, or use it to pick up some additional examples or something like that, which they can do. It's a glorified search engine, essentially. But when they just say, write me a report and then staple it and hand it in, we're going to know. And there's a lot of studies coming out right now about AI and its effect on teaching and learning and engagement. I do think there is a very high level of danger there, but I think the jury's still out in many ways, right? So I use it as a tool. Sometimes when we're doing product development stuff or things like that. But I think we do need to know that it has to be used responsibly. It's not Google. It may do something similar, but you don't just say it's Wikipedia or anything. It's not a source. It's a tool, and we can't use it as a source.
Great. Wow. Lots of information on this, right? We're like, oh man, we could do another episode on this, and we will, and we'll have Tom back. But talking about the different types of engineers, mechanical, electrical, computer, all these specializations. Parents, now you hopefully have it's kind of a springboard on what to search up on ChatGPT and how our kids and our students, our clients can kind of find their way through the sorting hat of areas of specialization in engineering. But the good news is you don't have to decide today. It's okay. Let's just focus on math and I can't even say it. The poetry.
The poetry of... And I would, to just go to piggyback on that, I think that's such a good point to make. when you get into the foundations of engineering, that's when you should figure out what kind of engineer
Yes.
you want to be. Don't go in saying, I'm going to be this engineer. I just want to be an engineer. And then let your coursework and your interests and what your strengths are help guide you to where you are going to be that expert.
Yeah, and that's true for I think that's true for a lot of different majors, right? That you can say,
teachers.
Don't go in pigeonholing yourself into one specific type without, getting that foundation, because the foundation will help you to decide later, where you want to be.
Right. So have fun with the Legos. We support the Legos.
We love
And
a Lego.
We
Nothing wrong
support
with a
you.
Lego.
And
Except when you step on them.
Except when you step on
they
them.
do
yes.
break skin.
Yeah.
So thanks so much, parents, for joining us. Thank you, Professor Tom.
Oh, thanks for having me. It was a great
us.
time this episode.
Love it. I'm Tracy Amadeo.
Tara Horitz.
And this has been From Carpool to College. Woo!
Thank you so much for tuning into today's episode. If you enjoyed what you heard, we'd love for you to be a part of our growing community. Please share and follow our show. For those who want to support us further, join our Patreon site. Your support helps us create high-quality content and great episodes. Plus, our Patreon members get exclusive perks like bonus episodes, early access, and behind-the-scenes content that we think you're just going to love.
And now for some legal stuff. The content of this podcast is for informational and educational entertainment purposes only and is provided as is with no guarantee of accuracy, completeness, timeliness, or outcomes. I could keep going, but I will spare you, and I will post this entire legal disclaimer on our website, www.academicmentoringllc.com, under podcast. Tara and I are so glad you joined us today on From Carpool to College. See you next time. Something like that.
Yeah,
Done?
that's good.
Okay, Chris, make that pretty, please. Pretty, please. Make it pretty, please. Thought maybe you were upset that you had nothing to contribute.
Yeah, I turned around I'm like, I'll give you a question.